Good morning everyone, welcome back to our natural language processing course, and today we will learn on chapter 7, technique in text classification and scikit learning tools which can be used to perform this kind of techniques. And here is the outline in this lecture. Firstly, we will review some important parts from our previous lectures, and next we will present the techniques which are used in text classification along with the tools called scikit learning. So let's review what we have learned from the previous week. So this is what we have learned from the previous chapter. We have seen the three different types of classifications. We have binary classifications, to which that we have only two possible outputs. So either one of them is the predicted label, and we have multi-class classifications that we have more than it can be possible that we have many labels, and only one label is assigned to the input. And last but not least, we have the multi-label classifications where we have many labels and it can be assigned to the inputs. It can be possible that there one or more labels. And from these type of classifications, we have different type of classifier. We also say it is binary classifier, multi-class classifier, and multi-label classifier. Okay, next we will review on the process in building a classification model. There are four main processes. The first process is called classifier initialization, where we need to pick a specific classifier to be used. And in the second process, we need to train our classifier, and in sklearn we can use the fit function. Then in the third process, we need to predict our new data, and then from the third process we have the classifier evaluation in the final process, in order that we can evaluate whether the performance of the classifier is high or expected our criteria. And if it is past our criteria, we will select this classifier. So in the classifier evaluation, we may have some criteria, some confusion matrix, some of the other evaluation methods like accuracy, precision, recall, and S1 score. In case that the evaluation is not past our expectation, we will take a look back to the first process, whether we should choose a new classifier or we need to collect more training data. To implement this using scikit-learn, we use some procedures. We need to initialize this using some specific function, like you need to use linear support vector classifier in support vector machine, and we have naive bias. However, to use this, you need to import it first, and next we can train them using the fit function, and lastly we can predict our model. And for the evaluations, we can use the existing functions to compute different evaluation metrics. And we also have learned on the types of datasets. We have two main sets called development set and test set. So in development set, we also further divide them into two different parts. We call training set and test sets. So in training sets, they are used to train our model. In case of supervised classification, we have the input and the correct label. So when we train our model, we can evaluate first using these data sets. If it seems to be okay, next we will have the final evaluation using another test sets. So the way we divide our data corpus, it is based on our scenarios. And what is accuracy and S1 score? Basically, accuracy is a ratio of correctly predicted observations to the total observations. It just like that, whether our prediction is correct or wrong, and then we sum them up and divide the totals actual values. So we will see some related terms, true positive and true negative. So what is true positive? It is referring to the number of correct predictions that the occurrence is positive. So that means we predict it is positive, and based on the actual answer, it is also positive. So it becomes true. So we say it is true positive. In case true negative, it is referring to the number of correct predictions that the occurrence is negative. So we predict it is negative, and based on our actual answer, it is also negative. So it becomes true. So we say true negative. And next we will see on the term S1 score. It is an average of precision and recall. F1 score is usually more useful than accuracy, especially if you have an uneven class distribution. So actually F1 score, we need to find precision and recalls. In precisions, we use it to find when a positive value is predicted, how often its prediction is correct. Whereas for recall, when the actual value is positive, how often is the prediction is correct. So from precision and recall, it gives us further analysis whether our model tend to predict based on actual answer or based on our predicted positive values. So from this, we cannot only use precision and recall to measure our model, but we need the average from these two types of criteria. So it becomes S1 score. So this is the formula S1 score. And next we have confusion matrix. It is also known as error matrix. It is a table used to describe the performance of a classification model, what we call it classifier, on a set of test data for which the true value is known in case we do in supervised learning. So this represents the prediction value from our model. This represents the actual values. So when the prediction is correct, we say it is, when the prediction we say yes, and when the actual answer also yes, so this means this is correct, right? So this is true positive because we predict it true. And we need to find these values, Tn true negative, Fn false negative, Fp and also Tp. And we have the classification report. It shows a representation of main classification matrix on a per class basis. This gives us a deeper intuition of classifier behavior over the global accuracy. So it gives us to find whether we have some weakness on one class of multi-class problem or not. So basically it gives precision, recall, F1 score, and some more features we call it support. And we also learned on how we can see on the implementation part. We initialize a model, we train our model, and next we predict a new data based on our model. And lastly, we can do some method to evaluate our classifier using the accuracy score, F1 score, precision, recall, classification report, and confusion matrix. And to make a further clarification on how we find these information, let's take a look on examples. In the sensor detection problems, let's say out of 100 of people, only 5 people they have cancer, and our model predict that all patients they have sensors. So next, let's try to draw a confusion matrix table. So from our hypothesis, from the exercise, we know that we have totally 100 people, but only 5 people have sensor. So this is the actual answer. We suppose that when the people have sensor, it is yes, or it is positive, and not have sensor, it is negative. So that means from this table, we have the actual answer is yes, which is has sensor, it is 5. and the remaining is 95 for no sensor. And our prediction from the model, all patient has sensors. So that means it is yes, it is 100 and this one is 0. So next we try to find the value for each of these. What is the number of TP true positive? So when the prediction is positive, it is correct, right? So we have 5, so that means this number is 5. And we have prediction 100, but actual answer only 95. So that means we got 95 correct. And next, for the actual answer, we have 5 sensor and our prediction is 0. So that means it's not correct, right? Because we don't predict at all. And next, we have the not have sensors, which is 95. And this one is not have sensor, it's 0 because we predict all patients have sensors. So from this table, we obtain these values, and this represents the confusion matrix representing our problem. So from here, we obtain this value, and next to compute the precision recall and S1 score, as well as the accuracy, we can use this formula. So the result from here says that we got 5% accuracy. However, if we take a look on recall, we get 100% right. But it seems that our classifier is not really efficient. So we cannot only observe only this. So mainly if we take a look on S1 score, it is an average between the precision recalls, and we got only 0.1. So when we see false positive and false negative here, we say this one, it is called 2 types of error. The first one is false positive, called type 1 error. Suppose that a person is not pregnant, but the prediction from our model, we say that this person is pregnant. Take a look on this picture. It is not correct, right? So our model predict is positive, but actually he is not. So it is false positive. And another type of error, we have false negative. This woman is having a pregnant. However, the doctor predicts something like she's not pregnant. So it is called false negative. And to the best of our expectations, the ideal scenario is that we all want the model should produce the false positive as well as false negatives to be 0. That gives our model the best. Okay, next we will take a look on the techniques which are used in text classification. We will pick the top 7 techniques. The first is logistic regression. Second one is net bias. Third one, stochastic gradient descent, or we call SGD. The fourth one is KNN, or it is called K nearest neighborhood. The fifth is decision trees. Next, we have random forest, and last but not least, we have support vector machines. In short, we call it SVM. And this type of techniques, they use different algorithms to perform the classification. So next, let's start with the first techniques called logistic regressions. We will go through the definition, advantage, and disadvantage, as well as the code implementation, how we can perform this technique in sklearn, and it also works the same way for the other techniques. And so what is logistic regression? It is a machine learning algorithm for classification, and it uses probabilities which describing the possible outcome of a single trial, and they are a model using a logistic function. So what is the advantage for using the logistic regressions? They are used to understand the influence of several independent variables on a single outcome variables. So what does it actually means? We normally take a look on the output, right? But for the input, we need to take a look whether it influenced because of some part of factor, for example, of the age, the gender, or some other informations. These are called independent variables. And what is the disadvantage of using logistic regressions? It is only work on binary classifications, as we have learned from the previous lecture. We have three main different types, but it only work on the binary classification, and we need to make some assumptions that all predictors are independent variable of each other, and the data is free of missing values. And next, we will take a look on how we implement the logistic regression in sklearn. So we need some required package. So from sklearn linear model, we import logistic regression, and these are used for evaluation criteria. We have accuracy score, S1 scores, contribution matrix, and so on. And as we have seen in the process of building a classifier, we need to prepare the data for training and prediction first. So suppose you have this data. This is used for the training, and this one is used for the predictions. So in training, because it is a supervised classification, we know that what is the training data and what is the correct label, as well as for the data for prediction. And next, we need to initialize our classifier, and we train our model using the fit function. Next, we predict our model using the predict function. And lastly, we can find the evaluation results, whether our model capture the correct results, how much it gives us. So we will see on this information from here. So basically, these are the important steps using the sklearn for implement logistic regressions. And the main part from the other techniques, we will mainly the main difference is how we import these techniques and how we initialize these techniques. Some technique may use some appropriate parameters. As we have learned, we call this parameter tuning, where a specific classifier is needed, and these processes working the same way. We need to train, and then we need to predict, and lastly we evaluate our model. Okay, next we will take a look on Bayes classifier. It is an algorithm based on Bayes theorem with the assumption of independence between every pair of features. So basically, it uses mathematical formulas, probably calculate the probability using the Bayes theorem, and it works well in many real-world situations such as document classification as well as spam filtering. And what is the advantage of using a Bayes classifier? It's only require a small amount of training data in order that we can estimate the necessary parameters. And the classifier is extremely fast compared to more sophisticated methods. So what does it mean? Comparing to the other methods, it gives you a faster performance. However, for the disadvantage of this Bayes classifier, it is known to be a bad estimator. Next, we take a look on code implementations. The difference between how we use different techniques is where we import the classifier as well as how we initialize it, and the other process working the same ways. And next we take a look on the third classifier, stochastic gradient descent. Actually, these type of techniques come from the gradient descents, which are divided into three main categories. We have batch gradient descent, stochastic gradient descent, and mini batch gradient descent. However, we will take a look on this one, which is give a more related information. And what is the SGD? It is a simple and very efficient approach to fit a linear model. So when you have the linear models, SGD is an appropriate technique that should be used. And the advantage of using SGD, it is useful when we have a large number of samples, which means referring to our training data. If we have a large amount of training data, it is good to use SGD. And it also supports different loss functions and penalties for classifications. So penalty here to avoid the overfitting and underfitting problems using in the regularization techniques. Penalty should be used to restrict our model to use its parameters. And lastly, it is efficient and easy for implementation. However, if we take a look on the disadvantage of using SGD, it requires a number of hyperparameters. It is sensitive to feature scaling. So you may need to provide different type of parameters. However, to restrict the way you give the parameter type here, we need to specify penalties. So this is how we implement in the sklearn. We need to import SGD classifier, and the way we initialize our classifier is a little bit different from the previous two classifiers that we have seen so far, because it requires some set of parameters. We have the loss functions, which type of loss function is used in this classifier that we want, and we need to have a variable called shuffle. We want to shuffle our data knot, and we have a random state. And the other process, it works the same way as the other two techniques. We have the fits our model, and we predict our model using a new data set. And lastly, we evaluate our result. So next, let's move on to the fourth technique. It is called k-nearest neighbors, or we call it KNN. KNN is a type of lazy learning. We call it lazy learning because it does not attempt to construct a general model, but it just stores the instance of training data. So each time you train these data, it does not construct a new model. It just stores the instance of the training data. Each time you train a new data, it stores a new instance. And the classification is computed from a simple majority vote of k nearest neighbor of each point. So we have a variable called k here. And the advantage of using KNN, it is simple and easy to implement. It is robust to noisy training data and effective if the training data is large. So if you have a huge amount of training data, we may consider KNN as well. And the disadvantage of using KNNs, we need to determine the value of k. Whether we want k to be a specific value, it can be 2, 3, 4, 5, or some other numbers. And the computation cost is high because it needs computer to compute the distance of each instance to all the training samples. So if we have the lower specification of computer performance, KNN may give you some more time to perform this method. And for the implementation part, we need to include the KNN classifier we call k neighbors classifier, and we need to initialize the classifier, and the rest of the procedure working the same way. And in way we initialize the classifier here, we don't need to pass any parameters in this case. So next we will take a look on the next techniques used in classification called decision tree, or it is short for DT. Given a data attributes together with its class, the correct label, DT produces a sequence of rules that can be used to classify data. So in decision tree, it is represented after tree, and we need the number of rules in order that the tree can be executed. And the advantages of using decision tree, it is simple and to understand and visualize our representation of data, and it also requires little data preparations. And lastly, it can handle both numerical and categorical data. And for the disadvantages, it can create complex trees that do not generalize well. DT can be unstable because small variation in the data might result in a completely different tree being generated. So if we have the small variation in the data, we may get a completely different tree, which is complicated generated. So suppose that we want to identify whether a person is short, medium, or tall. So first we will have rule to check whether they are female or males, and next we will check on the height. If they are in our expected height, they may fall into a category whether it is short, medium, or tall. So this set of rules should be defined. And to implement this decision tree in the sklearn, we use the same procedures. However, we need to import the classifier called decision tree classifier. And when we initialize the decision tree, we need some appropriate parameters, such as max depth, how deep that our tree can go. We have random steps, max feature, and minimum sample depths. And we also use the fit function and predict function, as well as the evaluation criteria using confusion matrix, accuracy scores, F1 score, and so on. Next, we will see on random forest, or it is called RF. RF classifier is a meta estimator that fits a number of decision trees on various subsamples of datasets. It's actually an improved version of decision tree, but where it can have many sub-trees inside. It uses average to improve the predictive accuracy of the model and control over fitting problem. The subsample size is always the same as the original input size, but the samples are drawn with replacement. And for the advantages of using random forest, it is a reduction in overfitting. There are not many overfitting problems, and random forest classifier is more accurate than decision tree in most of the cases. But for the disadvantage, it will be slow for real-time predictions, as well as difficult to implement because it has the complex algorithm. Next, we will take a look on how we can implement the random forest. We need to import the corresponding classifier, and we use the same steps as presented in the previous techniques. And for the classifier initialization, we need some of the appropriate parameters, for example, number of estimators, score, number of jobs, random steps, and so on. So we need to specifically understand what each of the parameter means when we want to use random forest, because there are many possible variation of the parameters that can be used for random forest. And we have the fit function, predict, and the evaluation result. Okay, last but not least, we will have the 7 techniques. It is called support vector machines, or in short, SVM. It is a representation of the training data as points in space, separated into categories by a clear gap. We call it clear gap. That is as wide as possible. So our trained data representation is separated by a gap, which is wide as possible. Then new inputs are then mapped into that same space and predict to belong to a category based on which side of the gap they fall. For example, we have this data representation, and from our model training, we separate our input data into two classes, class A in the red here, and we have class B. So this is the gap between these two classes, and we call this length is called margin, and we have this hyperplane line. And suppose that we have a new data to predict if it falls into this part, this location position, it falls to be class A's prediction because it is in the zone of class A. For the advantages of using SVM, it is effective in high dimensional space, and it uses a subset of training point in the decision function. So it is also memory efficient. So memory efficient is normally really important if we have a lower spec of computer to perform the classification task. And for the disadvantages is slow in real-time prediction. It's also difficult to implement as it has a complex algorithm. And how we implement this using sklearn, we can import this classifier using these statements from sklearn.svm, and from svm it has the support with the classifier, we call it svc. And next we do the same procedure. We prepare our training data and we prepare to initialize the classifier using some set of parameters. We have the canal. So in SVM there are different canal. We have linear canal, we have poly canal, and some other type of parameters. This is the value for the penalties, and we have the random step. And the rest procedure is we fix our model, we predict it, and lastly we evaluate our results. So for more details, we will take a look later on how we can use the right parameter based on our requirements. So for each parameter, it has different goals based on our objectives. So in addition to the techniques here, I would like to introduce some of the enhancement tools which are used in the classification as well as machine learning. The first one is called Jupyter Notebooks. It is a web-based interactive development environment. It's like an IDE, but it is run on the web. It gives you an easy access to your code. For example, if you run it on one time already, your data, your variable are stored. You don't have to run it again. So the trick behind here, they use different sections. So your code is run in different sections. So each time you want different section to be run, you can just activate it, and your variable, your data are also stored from the previous sections. And next we have the Kite plugin, which is used in the PyCharm IDE. It helps us to provide code completions. So just simply install Kite, then it will automatically integrate to your PyCharm IDE. So whenever you use functions, it gives you a code completion. Okay, next we have the homework, and we hope all of you will work together to understand more on how the accuracy, precision, and recall are presented, as well as to provide some more examples. And we have some other more information which are also useful to understand more detail in the classification. And we also take this link as the reference, and it also gives you important necessary information to describe these detail of each of information. However, we encourage you to have some more research on each of the detail here.